as you fade away, as you fade away.
Yeah, I'm about to fade away, cause every time I wake up I feel like it's Monday. Something's going wrong with all the chemicals up in my brain. All of a sudden I don't look at anything the same way. Gotta build up of my thoughts sitting in an ashtray. I'm sorry that I'm so inconvenient, okay. Just let me be me and I'll stay out of your way. I can see the way you look at me, I'm such a disgrace. I never really asked to be brought into this place. You wanna love me? Well then baby.
Alright, mic testing, mic testing. Okay, perfect. Let me go to my main camera. Already, we're live, and as you guys can tell by title and thumbnail, today I'm going to be working with, let's say, Scikit-Learn. This is more classic machine learning, where last stream I did work with machine learning, or the math and machine learning section, specifically applied math, where I worked with, let's say, calculus, linear algebra, and statistics. Actually, not statistics, I did work with probability. But today I will be working, let's say, with more of those topics. I forgot the, let's say, subcategory names, but let me go to my gameplay screen before that. I'm gonna switch this to RGB because, oh wow, that does the trick. Okay. I need to, like, save these settings, and is it, like, clear as well? Yeah, I am a bit late today. Is my fan on? There we go. Okay, yeah, I am a bit late, but I'm gonna increase my sharpness just a tad bit. Let's go to 56. I don't want it to look grainy, but I don't want it to look like blurry either. 46, 50 is good, okay. There we go, 50 works like a sweet spot. And then I'm also gonna on, let's say, Wuthering Waves while I go to my gameplay screen. And yeah, I did say since I'm live, and I will be starting a Pomodoro as well, where every 25 minutes I will be getting a 5 minutes break, and 4 sessions of 25 minutes I get a 15 minutes break. That's starting in 3, 2, 1, let's go! Okay, good evening, YouTube. Good evening, Web Universe. You just closed all of applied math, linear algebra, calculus, probability, and statistics. Done, taught, tested against real reasoning. Not just nodded along to. That is not a small thing. Most people who start these 365-day series never make it past phase 1. You're deep into phase 2 with the math bones actually built. Today we stop reasoning about numbers on paper, which we have been doing for, let's say, the past 2 streams, and start making a machine learn from them. And start making a machine learn from them. Oh, okay. And I will also get my Wuthering Waves here, just for the just for having it on once I hit my break time. Okay, that said, classic machine learning with Scikit-Learn. With Scikit-Learn, this is where every piece of math you just fought through, dot products, gradients, probabilities, stops being abstract and becomes the engine under the hood for real. Working model, before I throw syntax at you, one gut check first. Have you used Scikit-Learn import Scikit-Learn from Scikit-Learn or from Scikit-Learn import to yada yada before even briefly? Nope, never touched it. Haven't done squat about it. Okay, I will keep my desktop audio open at all times as well. Okay, never touched it. Good, that's the right answer to here because it means we build this clean. There we go, that's so much better. Okay, it means we build this clean. No half-formed assumptions to knock down first. Here's the thing you need to understand before we write a single line. Scikit-Learn is not magic. It's a library that takes everything you just learned, gradients, dot products, probability, and hides them hides the manual math behind clean function calls. When you call dot fit in a second, that's gradient descent running under the hood. You already know what that would mean. Nobody's cheating you here. Let's start with the single most foundational algorithm in all of machine learning, linear regression, predicting a number from other numbers using the straightest line that fits your data. First question before any code. You have a database of houses. Each house has a square footage of a price. You want to predict price from square footage. In your own words, no code yet. What do you think training a model on this data actually means? What is the model doing during that process? You have a data set of houses. Each house has a square footage and a price. You want to predict the price from square footage. I do not really, no, I am not warmed up as well. And yeah, I will be touch typing the stream. How many languages do you speak? No pun intended. Let's see. I speak English. I speak a little bit of Hindi. I speak, okay, would it count if I say I speak, I don't know, I speak like a little bit of Spanish. I need to learn more. Actually, you know what? I need to learn more languages, to be honest. I do speak multiple languages, but I'm not fluent in either one of them. English is mostly a language that I am really fluent in. Okay, that's it for enough. That's honest, and honest beats a guest answer every time. No penalty. Or I don't know. That's what we're here to fix. Let's build it from something you already nailed. A gradient descent from calculus. Remember that. You have a function. You wanted to find the lowest point and you took small steps downhill based on the slope. Trial and error. Just a guess until the error got small. Let's build it from something you already did. Gradient descent from calculus. Alright, I'm gonna go ahead and let's say open Visual Studio Code here, because this is where I had my .md file. And if you guys do want access to this markdown file, you guys can join my Discord server and ask it to me there in either, let's say, honestly, in the coding helps us chat. Or I will be later uploading this to my GitHub as well, so you guys can join my GitHub to get access to this. You guys can get access to my GitHub by typing exclamation GitHub on chat, all lowercase, no space. That said, where this shows up next, next session starts that stuff. Okay, I'm trying to see gradient. Gradient, I see distribution, okay. Probability and statistics. Where is gradient? There we go, gradient. The bundle of all the individual nudge directions combined to vector. Same one versus many relationship as dot product to matrix application. Alright, I didn't understand squat from that. Okay, let's build it from something you already nailed. Gradient descent from calculus. Remember that? Vaguely, but yeah. You had a function, you wanted to find the lowest point. And you took small steps downhill based on the slope. Oh, okay, I remember. Trial and error. Adjust a guess until the error got small. Okay, that does make sense. This has this much chance of succeeding. So increase the chance a bit more. Now it's too high up, so decrease the chance a bit more, if that makes a bit sense. Okay, linear regression training is exactly that. Applied to a line. Here's the mechanical picture. The model starts with a random guess for a line. Price equals to m multiplied by square feet plus b. M and b are just numbers, and at first they're garbage total guesses. For every house in your data, it plugs in the real square feet, gets a predicted price, and compares it to the actual price. The difference is error. It adds up how wrong it is across all the houses. It adds up, okay? Just like gradient descent, it nudges m and b a little bit in the direction that makes the total error smaller. Repeat steps 2 to 4 over and over until the error stops shrinking much. That's it. Training equals to repeatedly adjusting m and b using gradient descent until the line fits the data as well as it can. Quick check before we touch codes. In your own words, what are m and b actually doing in the line geometrically? You know this from basic algebra. Not new material. Just say it back to me. Wait, let me say. Before I answer the question, can you give me, let's say something like, can you give me a quick refresher as to what a gradient descent is question mark because I did not review it much. There we go. And it was just for the exposure phase as well. Let's go with something like descent. And also because of my microphone now being directly in front of my face, it's so hard to see what I'm typing. Maybe if I go a bit higher, I should. Oh, okay, now I should be able to see it, but then I'm too high now. What the hell? Now I'll just go a bit lower. Okay, that makes it even worse. Okay, fair, no shame in that. It's been a few sessions. Let's build it fast using arithmetic / mechanical framing that actually landed for you last time. Not the hillside stuff we know that does not work for your brain. Gradient descent mechanically, you have a number you're trying to guess correctly. Let's try the correct answer. Let's say the correct answer is hidden and all you get is a feedback on how wrong your current guess is. You start with a random guess. Okay. You have a number you're trying to guess correctly. Let's say the correct answer is hidden and all you get is a feedback on how wrong your correct guess is. Oh, I see. Okay, so it's like those games where pick a number. The number is too high, go lower. Pick a number. The number is too low, go higher until we don't hit that exact number. You start with a random guess. You check, if I nudge my guess up a little bit, does my error get bigger or smaller? What if I nudge it down? Whichever direction makes the error smaller, that's the direction you step. You take a small step that way. You repeat this over and over again. Each time, your guess gets a little less wrong. Eventually, your steps get tiny because you're barely wrong anymore. You've arrived at the best guess. Think of it like a hot and cold guessing game. Someone hit a number and they tell you after each guess is warmer or colder. You don't know the answer directly, you only know which direction reduces your error. So you keep adjusting in the warmer direction in the smaller and smaller steps until you basically can't get any warmer. That's convergence. The gradient part is the math term for which direction and how strongly does my error change if I nudge this number. The descent part is walk down the hill on the error. Example, keep reducing that error. That's the whole mechanism. Same logic you used for derivatives and a chain rule. Just applied how wrong is my line instead of an abstract function. Does that bring it back? It does. If yes, let's go back to M and B question. It does. Okay, now about the M and B question. Okay, in your own words, what are M and B actually doing? Price equals to M. I'm assuming M is my guess, right? M multiplied by square feet plus B. M is my guess. And B is the number that I add to it in order to reduce the size of my error. There we go, and then let's just go ahead and send it. Close, but let's tighten it up. You're mixing up which pieces does what. Here's the actual line equation. Gonna just get this here. There we go, that's so much better. Okay, so price equals to M multiplied by square feet plus B. Both M and B are guesses. A gradient descent adjusts both of them together to reduce error. They're not the guess and the correction. They're two separate numbers that each control a different part of the line's shape. Think back to plain algebra. Y equals to mx plus b, the formula of slope. I know that. You've drawn lines like this before. M is the slope. It controls how steep the line is in our case. For every square foot, how much does the price go up? B is the y-intercept. It's the starting value. When square feet equals to 0, it shifts the whole line up or down. Mechanical way to think about this, no geometry needed. if you only had a B and no M, every house, no matter the size, would get the exact same predicted price. Get the exact same, there we go. M is, okay, wait, what? If you only had B and no M, M is the slope. It controls how steep the line is. Yo, how doing, Topher? Appreciate you joining the stream. Okay, M is the slope. It controls how steep the line is. In our case, for every extra square foot, how much does the price go up? B is the y-intercept. It's the starting value when square feet is 0. Oh, I see. It shifts the whole line up or down. Mechanical way to think about it, no geometry needed. If you only had B and no M, every house, no matter the size, would get the exact same predicted price. M is what lets the bigger house get bigger predictions. B is the baseline. Everything gets shifted by, oh, I see. A gradient descent nudges both M and B at the same time, checking. Does increasing M reduce my error? Does increasing B reduce my error? And steps each one in whichever direction helps. Quick check, if M equals to 0, slope is 0. What would every single house get predicted as regardless of its square foot? 0, because B is, let's go with something like, because B is 0 as well. What are you doing? Actually, I am currently under a series called AI Engineering for 365 days, where my goal by the end of this series will be to, let's say, build a fully autonomous agentic AI. And in order to really build that autonomous agentic AI, I did come up with a roadmap, which let me pull it up real quick. Hold on. I did come with a roadmap that consists of 8 phases in total. Each phase getting relatively harder, but acting as the prerequisites that I would be needing in order to, let's say, make the agentic AI. Phase 1 was the bedrock phase, which I was done with. It got me exposed to a bunch of categories. For example, advanced Python. Each category had a bunch of subcategories. For example, in the Python's category, I had decorators, generators, context managers, async IO, async, yada yada. And then I moved on to the second category, which again had more subcategories. Same went with the third category of DSA that had a bunch of subcategories as well. And then another category with subcategories, categories with subcategories. And once I was done with all categories and all subcategories, before I really moved on to phase 2, there is a mini project that I had to build. And there will be a mini project at the end of every single phase that requires all these prerequisites that I have worked on in order to, let's say, build that mini project, where I did actually build a web scraper. Okay, I skipped the part that runs daily because that got too complex. However, currently I'm in phase 2, which is math and machine learning. And yeah, it is day 78. I am a bit off schedule here. Where in the last 2 streams, I worked with applied math, linear algebra, calculus, probability, and statistics. And today I am working with classic machine learning, Scikit-Learn, where I'm working with regression, actually. That was pretty much it. And if you guys do want access to my roadmap, you guys can get access to it through my Discord server. If you guys go to the Coding Helps Us chat, Python chat, or the general chat, mention my name there at WebUniverse, asking me for the roadmap. I will be personally DMing it to you guys after the stream is over, though. And you guys can get access to my Discord server through the link in the description, through my bio, or by typing !Discord on chat, all lowercase, no space. We're kind of close to 200 members as well. So a quick shameless plug for that. That said, mechanical way to think about it, no geometry. Okay, I see. Quick check, if M is 0, slope is 0, what would every single house get predicted as regardless of the square footage? 0 because 0, okay, 0 square feet because B is 0 as well. So there is, let's say, no slope to add to the price. If that made any sense here. Okay, careful. You're answering a different question than the one I asked. I said M equals to 0. I never said B equals to 0. Don't invent an extra condition that weren't given. That's not a reasoning error. That's not reading the question close enough. Slow down and work with exactly what's stated. We ask if m equals to 0 and b is just some regular number, b equals to 200,000. What would every house be predicted as? So 0 multiplied by square feet, so it would be 200,000. 200,000. This is 200,000, 20,000, 200,000. Exactly 200,000, and that's the real inside. When m equals to 0, square feet gets completely erased from the equation. A 500 square feet shack and a 10,000 square feet mansion both get predicted at exactly 200,000, unless useless model. That's why m matters. It's the only thing letting square footage actually influence the prediction at all. It's just the flat baseline everything sits on top of. Good, that's the full picture now. Trading equals to gradient descent, nudging m and b together until the lines' predictions are as close to the real price as possible across your houses. Now we write actual code. First time touching Scikit-Learn. Here's the real price shape. From Scikit-Learn.linear_model, import linear regression. Okay, this is something that I have not worked with. I most likely need to install my Scikit-Learn. Okay, hold on guys, give me a quick little second. Okay, let's see. So, model equals to linear regression. Models are the fit method x and y. 3 lines that genuinely most of it, but before you run anything, prediction time. Since you do have real grounding to reason from now, x is your input data, square footage, y is what you're trying to predict. Price, based on everything we just covered about what .fit needs to do internally, what do you think model.fit xy is actually doing when you call it? What comes out of the other side stored in the model? Okay. Hold up. I think I didn't read that properly. Wait, before I go with any of this, let me say something like, let's say, before we work with... Guys, my mic is getting in my eyes. What the hell? With any of this, do I need to install anything? Question mark. I do not have, let's say I do not have Skit installed or Scikit-Learn installed. And if so, let's go with something like, if so, what is the command that I would need to use? Let's go with something like need to use in order to install it. I'm pretty sure it is py-f install yada yada. Okay, good catch. Yes, you need it installed before any of this runs, since this is terminal command per your rule. Here it is for approval before you run this. So py-m pip install skit-learn, okay? Breaking down. Okay, I know what these things do. I just wanted to know the library's name. Therefore, I'm gonna go ahead and let's say move on to my phase 2 here. Markdown nodes goes under phase 2. Okay, I'm gonna go... No, let's go with Control Z again. There we go, okay. I'm gonna go ahead and go under my Python files, and we're gonna create, let's say, another file called skit-learn.py. Does this make sense? Hold on. I'm gonna go with something like uppercase S, and then L is gonna be upper title cased as well. Learn. Okay, and then I'm gonna hit enter. Now we're gonna go ahead and click Control plus / to grab our terminal launcher, and then I'm gonna go ahead and paste this. This is gonna in turn install our Scikit-Learn. Downloading Scikit-Learn. There we go. Guys, my big mic is in front of my face. What the hell? I can't see anything. Oh, wow, this looks like a massive library. You know what? Screw it. I'm gonna go ahead and copy that, grab Claude here, and then let's just go ahead and paste it and say something like done, exclamation. I would go with exclamation, I'm just gonna say done. Okay, next up, once we actually have our Scikit-Learn installed. Scikit-Learn installed, Scikit-Learn 1.9.0, clean install, no errors, that's all we need to see. Ignore the pip upgrade notice, it's a noise, not a problem. Skit-learn pulled in Skype2, that's normal. Skit-Learn is built on top of it, no action needed there. You're set up, and now back to the real question. Since you skipped past it to handle setup, let's not let it slide. Come back to it now. Model.fit xy, x is square footage input, y is price. What you're predicting, based on everything we just walked through about gradient descent, finding the best m and b, what do you think .fit method is actually doing internally and what ends up stored in model once it's done? Okay, let's see. So, this is the code here. Model is going to be our linear regression. Model.fit. The only one possible thing that it could be doing is, let's say, this is not, me using, let's say something like using my brains or thinking critically. Oh, guys, the mic is in my face. Okay. I believe that it does the only thing that we, let's say, talked about. It will use trial and error in order to reduce to smaller or to shrink the errors and have a best guess. There we go. Okay, that's it. That's time. Hands off anything that is not distracting. Moving on to Wuthering Waves. Okay, so where did I stop last stream? I kind of forgot. So I need to continue exploring. I think I stopped here last stream. Okay, and I'm just gonna go ahead and grab my timer down here because it's like too big. What the hell? And then I'm gonna kind of truncate it from the left as well, from the right as well. Guys, this is so convenient for me to get videos for my gaming channel as well. Wait, I was about to fight these beasts, right? Level 90. Let's fight this level 90 beast. Let's go. Oh, and I may need a skill anytime soon.
I'm okay. Storm, hear my command.
Storm, hear my command. There's more.
Please, don't worry.
The commotion. Serenade. Is that what she said?
Shape the shapeless.
Shape the shapeless. All right, I think we're done.
Speed it
Moving
up.
on. Defeat the enemies along the way. Okay, so we gotta beat these enemies along the way. Thank you for the stuff, I guess. All right, moving on.
Beware.
Oh wow.
Please.
There are a bunch of auto puppets here.
Hey! Deference.
Difference. There we go.
Speeding up.
Further investigate. There is more investigation to do. You know, this is the one time that I did not really want to do this. I was trying to getting curious about.
Those are Xuanfang Wardens.
Yeah, I was getting a bit curious as to what we were going to be working about in the machine learning, but I'm going to be done with this quick.
Liangyu scouts. This must be them. No sign of life.
Yeah, I was going to hydrate my lips. Hold on, let me hydrate my chapped lips real quick. Okay, so we need to continue forward. Let's go forward.
Too many. Engaging them would cause too much noise.
It
Need
would.
to find another way.
Oh, wow. Oh, wow. There are so many. Continue forward. Am I stuck? What the hell? They don't let me go there?
Speeding
Fine.
up.
Oh, we're taking alternative path. Speeding up. We gotta go more? Can it just give me like one pointer and I can just run 300 meters away? Wow, further in... Oh, wait, that's far away. Okay, let's take a rest. I'm gonna
Against the
jump,
winds.
then I'm gonna hit T. You have left the quest area? What do you mean? What do you mean I left the quest area? What do you mean? Oh, okay, maybe I was in the sky, that's why. Alright, now, 50 meters away, I see someone right in front of me. I wonder what he's...
Speeding up.
Speeding up. Wonder who they are.
Halt! Who goes there? Identify
Lin-
yourself.
Linean? Yang Yang gives the guards a quick briefing. I'm so glad we didn't get to hear the
So
briefing.
Watcher Liang Yu sent you to map a route. Good. We've been waiting a long time.
Also, I found scouts along the way. They're already...
I see. Thank you for telling me. They were long overdue, so I feared as much. No time to lose. We must send word to Liang Yu immediately. Good work. The camp is just ahead. I'll find you a place to rest.
Alright, I guess we're resting. Oh wow, 50 asteroids and sky scrimp. Wait, hold on. H armory newfound. I'm not gonna go there. That's it. Hands off anything that's distracting. Back to work. That's time. Hands off anything that's distracting. Moving on. Where was I? Okay, I replied to Claude saying this is not me using my brains or thinking critically, I believe. Okay, I gave it the guess. That's not a cop-out. That's actually what you've been thinking, not guessing. You tied it directly back to the mechanism we built instead of inventing something new or blind guessing. That's exactly the reasoning I want to see. You're right. .fit method, xy, runs gradient descent internally. It starts with garbage m and b, checks the error across every house in your data, nudges both numbers in the direction that shrinks the error, and repeats until it converges. Once it's done, the best m and b it found gets stored inside a model as attributes. You can literally go look at them after training. Model.coef underscore. Is that like coefficient? Like, does coef stands for like coefficient? This is m, the slope array, since you could have multiple inputs. Model.intercept underscore. This is b. Oh wait, this is for me looking into them. Oh, I see. So coef underscore. This is m, the slope. And intercept is b. So y, b is the y-intercept. Coef is m, which is the slope. Note that trailing underscore, that's a Scikit-Learn convention, not an attribute ending in underscore. Means this was learned from data, not something you set yourself. Here's your real hands-on task. For our loop, you run it, send me the real code and real output task. Using this tiny made-up dataset of 5 houses, train a linear regression model and print out the learned slope and interpret and intercept. Square feet equals to a list. Okay, why is 1,000 in a list? I don't get it. Square feet equals to a list of 1,000, 1,500, 2,000, 2,500, and 3,000. Price is 200,000. 250,000, 300,000, 350,000, and 400,000. Note, square feet is a list. Wait, square feet is a list of lists. Scikit-Learn expects two-dimensional input for x. Don't worry about y yet, just match that shape. Before you write it, a prediction time given this data is a perfectly straight line. Each plus 500 square feet exactly plus 50,000 equals to exactly plus 50,000. What do you predict model.co with and model.intercept underscore will come out to? Let's see. I think it's gonna come out to 50,000. Okay. Oops. Let's go with something like 50,000. What the hell? Oh, there we go. Okay, that said, I do not know the syntaxes that I will be using here. And I am mostly, let's go with some, oh god. And I am mostly mostly going blind in this because even though I understood, let's say something like even though I understood the concept, the topic, theoretically, I do not understand it in terms of explaining it. Okay, there we go. Even though I could explain it to you guys if you asked me theoretically. Now let's go with theoretically. Syntax is SYNTA. Yeah, I can manually fix them, but I'm just gonna go back here. Hey, Vivek is back on the grind. Let's go. You're hiding formidable thunder. Appreciate you joining the stream. Okay, let's see. 50,000 for the slope, correct? That's the right prediction, and it's not luck. You just computed it the same way gradient descent would converge to it. Plus 500 square feet always gives plus 50,000. So M has to land on 50,000 for the errors to hit 0. Good. You skip the intercept part of the prediction, but that's fine. Wait, the intercept part would be 500. It's plus 500 square feet always gives 50,000. Okay, you skip the intercept part. Let's get it from the data itself instead of guessing. Square feet 1,000, price 200,000. If slope is 50,000 per square feet, then 1,000 multiplied by 50,000 equals to 50 million. Way more than 200,000. So B has to be large. Wait, is this 50 million or 5 million? 50, 100, 5,000, 50,000, 500,000, 5 million, 50 million. Okay, it is 50 million. Okay, what did you get up to last session? Actually, I just said that, but let me say it again. Sorry, I wasn't here because I had school. Hold up, let me grab my roadmap here. I did say it like a while ago, but I could say it again. Last stream, I was still working with Phase 2's machine learning, where I was under the category of applied math. I was done with all 3 subcategories, which consisted of linear algebra, calculus, probabilities, and all that stuff, and all the subcategories inside the subcategories. Today, I'm working with classic machine learning, which is Scikit-Learn, where I'm currently working with regression, the first subcategory in it. That said, way more than 200,000, so B has to be a large negative number to pull that back to 200,000. We'll see that number once you run it. Now, the syntax gap is completely normal. You've genuinely never touched this library, so going blindly on syntax isn't a knowledge failure. It's just day 1 of a new tool. Here's the actual code, fully shown, nothing hidden. So, from skitlearn.linear_model, I want to import linear regression, all title cased. And then I create a square feet variable that is going to be a list of lists, which consists of the square feet. Price is going to be a list of prices. Okay, probably because square feet is our slope. The submarines. Okay, that said, model equals to linear_regression function, the function that I've imported here. And then model.fit is what actually executes the gradient descent internally. Where I have square feet as my slope and price as my b, which is my y-intercept. I print slope, which is going to be model dot co f underscore, and intercept is going to be model dot intercept underscore. Walk through it top to bottom before you run it. I did that stuff. Copy that into here. I'm not gonna copy it because I want to understand these syntaxes too, so I'm gonna type it out. So first things first, I'm gonna go with something like, let's say I will be having it as a reference because this is my first time. I guess this is gradient stuff. Actually, it is. I had a hard time understanding it, but then now that I got some practice with it, gradient is basically using trial and error until the error seems to be at its lowest or at its smallest, which is considered the best guess that we get. That said, let's go with something like from Scikit-Learn. From Scikit-Learn dot linear LEANLINEAR dot linear underscore model. I want to go ahead and import, let's say something like linear regression. Okay, linear regression is the function that I will be using. I'm going to be creating a sqrt variable that is going to be equal to a list of lists, where I'm going to go with a square feet of 1,000. And then I'm going to add a comma, go with another list of, let's say, 1,500 square feet. I increment or I increase my square feet by 500 every single time here. Okay, there we go. This is going to be 2,000. I'm going to try to chop here. How in the world do I chop if my fingers are not used to my touch typing it? This is going to be 2,500. Okay, but I'm going to say it's much better than before. Only thing that I mess up with is the commas and the periods. There we go, okay. 3,000. And then we have 3,000 as its last. 1,000, 1,500, 2,000, 2,500, 3,000. Next up, we're going to have prices, where the lowest price of a house, where prices is going to be a list. The lowest price of just 8,000 square feet is going to be $200,000. 200, 1,000, 20,000, 200,000. Let's say the price for a 1,500 square feet model or house is going to be $250,000. Let's go with 2,500, 25,000, 250,000. And then we're gonna go with, let's say, 300,000. Oh god. Guys, I swear this touch typing is getting on my nerves. 300,000. And then we're gonna go with something like $350,000. Is that 50, 350, 35,000, 350,000. And then we're lastly gonna go with 400,000. Alright, once we're done with that, when the machine gets the line to the best align with the data slash points. Oh, I see. Though gradually adjusting values through gradually adjusting values. Okay, actually that was way better than my explanation. Okay, next up I'm gonna go with something like model. My model variable is going to be equal to my linear underscore regression function here. There we go. Which is gonna be invoked by parentheses. And then I use the model dot the fit method, which actually applies the gradient descent internally. That is going to be requiring two parameters. The first parameter is going to be my slope, which is going to be my square feet. And then I'm going to be requiring my y-intercept, that is going to be my prices. Alright, once I'm done with that, I'm just going to go ahead and add two print statements. The first print statement is going to be an f string, and it's going to go ahead and print my slope. There we go. My slope is going to be my m, which is, let's say, going to be of curly braces. Oh god, are you kidding me? There we go. Okay, which is going to be my model dot the coef underscore, was it this? Okay, it was this. Let's go. And then the next thing that I will be adding is another print statement with an f string, which is going to be printing my intercept, intercept, where my intercept is going to be my b, where I'm going to add a curly braces here, pair of curly braces, and go with something like model dot, let's say, intercept intercept underscore. There we go. Slop. Internet slop. Okay, let's go with controllers to save the code. Now, I'm gonna go ahead and run the program. However, before I really run the program, I'm gonna change my directory to the exact path that I'm currently at. I'm under my Python files. So I'm gonna go with change directory to, let's say, something like Python underscore files. Okay, and then once I'm done adding my Python files, we're gonna go ahead and, let's say, run our file directly through our terminal, because apparently I did the mistake. Well, not a mistake, I did change my encoder to UTF-8, so now when I use code runner, it literally does not run my program. Okay, I'm gonna go with py, Scikit-Learn, Skit-Learn .py. Okay, let's see, wow, it's taking a while to actually give me an out. Oh. Part of this app has been blocked. Some features may not work. What the hell? Import error. Scipy install you're using seems to be broken. Extension modules. Wait, why do I get this error? Hold on. From Scikit-Learn. So from Sklearn dot linear underscore model. I want to import linear regression. Interesting. Okay, just hypothetically, if I were to paste clauses, it's the exact same program. And then I'm gonna go with Control Z. Yup, it's the exact same thing. I'm gonna grab Claude out here real quick. There we go. Hey, you're pretty smart for a 10-year-old Kappa. Guys, wait. I'm gonna imagine that wasn't a comment meant for me. I'll pretend that you were talking to someone else. I'm 18, by the way. Okay, let me say something like, I run into an error. And then I'm just gonna go ahead and, let's say, paste my error here. Okay, because I did get a notification saying that some of the contents from here were blocked. So I wonder if it's just my PC or something like that. Kappa are Japanese though, I see. Okay, good, you ran it and sent real output. That's exactly the loop working right. Now let's read this like a real debugging problem. Instead of panicking at a wall of red text, look at the actual root cause. A root cause line, not the top of the traceback. Read, okay, traceback reads bottom up. For the real cause, import error. DLL load failed while importing underscore CY utility. An application control policy has blocked this file. I knew it. That's not a Scikit-Learn problem, and it's not really a broken spicy install either. It's just the symptom that the root cause is an application control policy has blocked this file. That's Windows itself, most likely something like Windows Defender application control. Okay, I just got to disable it, right? A corporate/school security policy or a third-party antivirus actively blocking a .pyd/dll file. That's Scipy needs to load because it doesn't recognize or trust the compiled files. This is a machine security policy. Okay, is this a personal PC you fully control or as a school? Fully my own PC, what the hell? On Twitch, Kappa signifies irony or sarcasm. If try implementing linear regression instead of just using a pre-built. Actually, I think I should do that as well. I'm going in a, whatchamacallit. I'm just following the roadmap here, so later on I am positive that I will be applying the regression as well. I thought we were on YouTube. I thought that as well, aren't we on YouTube? Okay, good, that simplifies things a lot. Fully your own machine means you have the permission to fix this yourself, not IT ticket, okay, blah blah blah. First, a read-only check. No changes to your system, just look at a recent security log. Get event. This is a terminal command, so per your rules. Okay. Okay, so apparently I gotta run this. Alright, so let's just go ahead and paste this real quick. Alright, and now if I were to go ahead and run my py_skit.py, which is my Python file here, well, it executes. It's taking long again. Okay, using ID, signature. Hold on, I guess let's just wait for it to load. And I can't see anything because I can't see half my screen because of my microphone here. What the hell? Time created, information, ID, message, editor, smart app block, okay. Alright, am I expected to wait? So the 12-year-old message was a joke, Viv? Oh, I see. Huh. I'm still waiting, by the way. Device hard disk volume 3. Okay. Name error. Name linear regression is not defined. Did you mean linear regression? Okay, everything was correct. It's just our typo. Wait, why did I go with an underscore? What the hell? There we go. Okay, that should make it. That should fix the error. I want to see what did Claude say me to type though. So what I typed was get -win event log name Microsoft -Windows -code integrity / operation max event 5. Okay. Wait, okay, wait, what the hell? How did I manage to mess up my spelling twice? Okay, and then I'm gonna go with py Scikit-Learn.py. Let's paste it, and this time I'm positive it's gonna work, because there we go. Our slope is 100 point, and our intercept is $100,000. Okay. I'm gonna go ahead and copy this. Let's grab Claude here and say I get this output. However, it is quite different. Let's go with something like different from our predictions. There we go, and then I'm just gonna go ahead and send it. Have you ever thought about streaming on Twitch? Actually, yeah, I did, but then the downside to streaming on Twitch as well is that it does decrease my YouTube's stream quality, or my stream quality in general across the platforms if I do simultaneously stream. That's one reason I dropped my vertical stream as well, and also a reason why I was trying to use Restream.io. Honestly speaking, I may actually simultaneously stream on only Twitch and YouTube. You know what? That's not a bad idea. They've used autocomplete for preventing. Okay, now he might stream on BitChute though. I've never heard of that. They've used autocomplete for preventing more spelling errors. Wait, did I make any typos? The thing is, I want to get better at touch typing. That's the reason I am still getting errors. However, it is like much better than it used to be to honest. My god, back in the days when I used to type, I used to have 90% of errors. Like, all my text used to be literally red squibbly lines. That said, hold on, you skipped the diagnostic command and just ran the script and it worked this time. That's worth noting, but not chasing right now. Could have been a transcendent AV scan check, Windows re-evaluating the file, whatever. It's resolved itself, so we move on, not backwards. But you're right to flag the numbers. They're wrong, and this is exactly the kind of thing we catch. Not wave past. Your predicted slope is going to be 50,000. You got a slope of 100. And the intercept was predicted to be 200,000, but the intercept was 100,000. That's not even close. Before I tell you why you debugging this first, look at your data again. So square feet, wait, it's not square root. I went with, okay, my bad. Square feet is going to be 1,000, 1,500, 2,000, 2,500, 3,000. Price is all that. 1, 2, 3, 4, 5, 6. Okay. Walk it manually the same way you did to predict 50,000 the first time. From house 1 to house 2, square feet goes from 1,000 to 1,500. A change of 500. Price goes from 200 to 250,000. A change of 50,000. Slope equals to change in price divided by change in square feet, which equals to 50,000 divided by 500, which is 100. Look closely, 100 is actually wrong. Or we did make an error in our prediction earlier, or did we make an error? Okay. We made an error in our prediction. earlier. There we go. Sounds like a skill issue. Honestly, it actually is a skill issue. That said, correct and good. You went back and actually checked it instead of just taking my word for it. That's the debugging instinct we want. Let's be precise about where the error happened, because we made an error is true but vague. I want you to see exactly what went wrong in the reasoning, not just accept that it was wrong. Earlier, I said plus 500 square feet equals to exactly 50,000 and asked you to predict the slope, and you said 50,000, but slope isn't the amount priced. But slope isn't the amount price changes. Slope is price per unit of square feet change. You have to divide 50,000 increases. The $50,000 increase happens over a 500 square feet increase, not over 1 square feet. So slope equals to 50,000 divided by 500 square feet, which equals to $100 per square feet. Huh. Do you stream every day of the week? Actually, yeah, and weekend. Yeah, I do stream like every single day, including the weekends as well. That's it. That's exactly what the model found. 100.0. The model was never wrong. Our mental math skipped the division step. This is good catch because it's the exact same mistake pattern as your earlier die-roll repeating. Decimal slip rush past a division / ratio. Okay, so it was basically a math mistake and not a programming error. Now the intercept, 100,000, does that make sense? It actually does. Slope is, okay, so 50,000 increase happened over a 500 square feet increase, not over 1 square feet. Square foot is going to be 100, so 500 square feet. I see. Okay, now the intercept, 100,000 doesn't make sense. Check it yourself. Plug square feet equals to 1,000 in the formula. Price changes from 100. Okay. And solve for B using the real intercept the model. Alright guys, hands up anything that is not distracting. Back to Wuthering Waves. Oh god, I really wanted to read the whole thing. This period was not the most productive, but oh well. I see. Wait, please tell me my desktop audio was on. Let's go, you guys heard the humming. Last stream I couldn't hear the humming, but it actually sounds kind of good. Okay, so rest up in the garrison camp. Where is the garrison camp? Okay, I'm lost.
Speeding up.
Speeding up. Okay, where is the garrison camp? 30 meters, 27 meters, 29 meters. Oh wait, it's here. Okay, I see. There we go. Is this the camp? Wait, F to sit. There we go. Did it just say Jalebi subscribed? Safety. Wait, did it? The Indian Swede. Okay, it's basically filled with. It's just basically diabetes waiting for us. I hope everyone makes it through safely.
Excuse me, miss. Do you have a rafter kite with you? If it's not too much to ask, could you let it carry a letter for me? A letter home to Manjo.
I'm gonna get this here.
You mean to...
I've been away from home for many years now. Now Shangfan has fallen into chaos. I may never see my wife and children again. This letter is my last wish. I asked every soldier in the hold, but they all say that under these circumstances, every rafter kite must be reserved for military reports. Please.
It's all right. Give me the letter.
Why is that actually sad? What the hell? Why not Genshin Impact? Because Genshin Impact is not as free-to-play as Wuthering Waves. I think Wuthering Waves has a lot of free-to-play content in it as well.
Thank you. Thank you. Oh, thank you.
I feel so bad for him.
I hope the first thing his family sees is not this letter, but the man himself returning home.
Yeah. Or Zenless Stone Zero. I've never heard about that. Is that like a gacha game similar to Genshin Impact?
Father. Mother. Rover. Sister said she'd come visit Jinzhou soon. If she can't find me, will she worry? Maybe I should write down what I've seen here. If nothing else, I can put the clues in order. Perhaps it will help whoever reads it.
Oh wow. Right about Xiangling village and the rafter kite.
Since entering the land of Xuanfeng, I have been set upon by both autopuppets and Tessa discords. For what cause I was targeted, I cannot say. But the Xuanfeng wardens pulled me from the brink, and that is how I came to Sanling village. Somewhere along the way, a mechanical bird began to follow me. The locals call it a rafter kite. They say it was modeled after a spirit bird that once dwelt in Xuanfeng. It is remarkably clever. Now and then, it seems to lead me to places, almost like a real living bird.
Wait, is that basically like AI birds? Right about Liang Yu.
In Sanling village, I met Liang Yu. She is young, yet she already holds the title of Xuan Watcher. She told me of the chaos that has swept across Xuanfeng. Her squad mates were slaughtered in a censure court. Something in her reminds me of who I once was. If I can, I will lift some of the weight off her shoulders.
Right about the rogue auto puppets.
The auto puppets meant to purge tacit discords have gone rogue. They now attack the people. I can't prove it yet, but something tells me this isn't just a malfunction. It's deliberate. Someone's behind it. But Xuanfeng Hold's comms have been cut. The wardens are barely holding the line against both auto puppets and tacit discords. No one has the time or strength to find out what's really going on. If only I could gather some clues through the streams.
This is the longest report of my life. Okay, that said, hands off anything that is distracting. Back to work, back to work. Let's get my timer up here. Please tell me there's no conversation going. There's some conversation going in the back. Oh, are you kidding me? Okay, that said, I think I'll see that later. Okay, correct and good. You went back and actually checked it instead of just taking my word for it. That's the debugging instinct we want. Let's be precise about where the error happened because we made an error. Is it true? Is because we made an error. Is true but vague. I want yada yada. Okay, wait, I read that, right? Now the intercept. Okay, I think I was gonna like manually try this. So I'm gonna go ahead and change my square feet to, let's say, what was I expected to change it to? Okay, now the intercept is 100,000. Does that make sense? Confirm it lands on 200,000. Does that make sense? Check it yourself. Plug square feet equals to 1,000 into the formula. Price equals to yada yada. Okay, so price equals to 1,000 multiplied by square feet and solve for B using the real intercept. So 1,000 multiplied by square feet, which is gonna be what is 1,000 multiplied by 1,000? That's like 10,000. 10,000 plus whatever B is. Okay, you know what? I'm bad at the math part. Okay, I see how that let's go with something like how that makes sense. However, is there a way that I could fact check it? Let's go with something like fact check it through my VS Code question mark. Okay, let's go with something like because I am bad at math. Okay, guys. Okay, I haven't taken any math courses, alright? Okay, good. Instinct verifying with code instead of trusting. Mental math is exactly the check real output discipline you already know for, blah blah blah. Okay, now yes. Absolutely, you can have the code check instead of your head. Add this to your script. So predicted equals to model dot The predict method. I have never worked with the predict method. Print predicted price at 1,000 square feet. Predicted. Okay, model.predict takes a new input, same two-dimensional shape as before, a list of lists, and runs it through the learned M and B automatically. No manual arithmetic required. The model does 100 multiplied by 1,000 plus 100,000 internally and hands you the answer. Okay. Before you run it, quick prediction. Okay. How is the... Okay, the slope is 100 because... So dot predict method. Alright. Okay, the slope is 100 because we go with something like our square feet, which increases by 5,000 every time, and our price, which increases by 50,000 every time. We go with those two increases and divide them together, which gives me 100. So 50,000 divided by 500 is going to be 100. Now let's go with something like prediction is going to be equal to, let's go with something like, I don't know, was it model.predict? There we go. Okay, I'm gonna go with something like model.predict. Was it title cased or not title cased? Or lowercase predict, which is going to be a list of 1,000. Alright, so predict, which is going to be a list of 1,000. And then I'm gonna go with, let's say, a print statement. My print statement is going to be an F string that is going to say something like prediction, prediction. That is going to be, I don't know, let's go with something like prediction. prediction. And then I'm going to hit controllers to save the code, and let's just go ahead and run it. I'm gonna copy my py Scikit-Learn.py just to run my program. Okay, there we go. The prediction is 200,000. Okay, I see. And then let's paste it and see and say, I see. I believe that I understood this for now. However, I will need more practice, which I am sure that we will get further on in this series, right? Okay, because whenever I work with a new topic, let's just type it, because whenever I work with, let's say, a new concept, it is a more, it's morely for exposure as opposed to the mastery itself, right? There we go, and then let's just go ahead and send it. Okay, 200,000 exactly matches the actual price for 1,000 square feet house. The module predicted it perfectly because that data point was literally in the training set you just verified with real code output. And the predict method does exactly what we said it does. No math required, no guessing, good. And yes, you have that exact right, and you didn't need me to remind you. You pulled it from your own pacing philosophy. This series is built on exposure first, not mastery first. For the people who are actually following this roadmap, do not worry much about mastering every single topic before moving on to the other topics, because every new concept is just getting you exposed to what is it that you really are expected to know and work with later on in the series. So every topic, you guys will be getting enough practice, so don't worry about mastery. Okay, you're not supposed to walk away from today being a linear regression expert. You're supposed to walk away knowing what dot fit does mechanically, gradient descent, same math you already learned, what dot predict does, what coef, which gives us the slope, does, and what intercept, which is our y-intercept mean. You can verify models math with code instead of doing it in your head. That exposure mastery comes later, the same way it's coming for Bayes' theorem. Through repetition across future topics, native Bayes, other regression variants, a real project do work, not by grinding this one. Not by grinding this one example into the ground right now. You did good work this session, really building that solid stopping point. Oh, hell no. I can still continue. Okay, we have just been working for an hour. Okay, and then let's just go ahead and send it. Good yourself checking, yada yada, blah blah blah. Okay, next up, logistic regressions. I currently worked with, what was it called? With linear regressions, there we go. And despite the name, don't let it fool you, it's not predicting numbers like price, it's for classification, predicting a category like yes/no, spam/not spam, pass/fail. Quick gut check before we go anywhere near the code or theory. Have you ever used logistic regression before, even briefly in any context? Nope, never touched it. These are all brand new concepts for me, I've never learned squat from here. Okay, never touched it. Good, clean slate. Same as linear regression before we started it. Let's build it the same way. From something you already understand, not from a textbook definition. Here's the setup. Say you have data on students, hours studied, and whether they passed or failed the exam. With linear regression, output was a number. Price, any value, could be $200,000 or $310,472.19. No ceiling, but wait, with linear regression, output was a number. Price, any value, could be $200,000 or $310,000. No ceiling. With linear regression, that's it. Okay, but pass or fail isn't a number like that. It's one of exactly two categories. So here's the real question. Reasoning only, no code. If a model needs to output pass or fail, but under the hood, everything in these libraries is still a number in math, how do you think a model could represent pass or fail using a number? What numbers would make sense to represent those two categories? Wait, I did not understand. Let's go with something like I did not understand 75% of what you just said. Could you explain it to me using a real world example question mark? Let's go with something like world. There we go. Okay, and then I'm just gonna go ahead and send it. Maybe I'm gonna drink some water real quick. There we go. Oh god, I haven't hydrated in the last hour. And I need to make sure that I don't really spill my water anywhere because apparently I'm surrounded by electronics. Okay, fair, let me stop and rebuild this lower with something concrete instead of talking in the abstract. Real world example, forget about models for a second. You're a teacher. A student asks you, do you think I'll pass the exam? You don't just say yes or no out of nowhere. In your head, you're doing something like, they studied 8 hours, that's pretty solid. So, yeah, probably. I'd say like 85, I'd say I'm 85% confident they'd pass. That's the whole idea behind logistic regressions. Oh, I see. Instead of jumping straight into pass or fail, the model first calculates a probability, a number between 0 and 1 or 0% to 100%. Say there were a child who left a mess of toys. There are 2 buckets that you ask them to organize the toys into. That's classification. Ah, I see. So is it basically filtering one toy from the other toy, or just like having them be in two separate buckets, so one bucket is not like overfilled. If they do red toys in one bucket and blue in the second. Okay, so it is like filtering stuff, I see. Like your gut check confidence as a teacher, then only at the very end it converts that probability into a final answer. If the probability is above 50%, call it pass. If it's below 50%, call it fail. Oh, I see. Okay. So concretely, a student studied 8 hours. Model calculates 92% chance of passing, since that above 50% answer is pass. Student studied for 1 hour. Model calculates 10% of passing. Below 50, final answer fail. That's it. That's the whole mechanism in plain terms. Predict a probability first, then draw a line at 50% to make the final yes/no call. Does that version land better? If so, the same question as before. But now with the teacher picture in your head, why does it make more sense for the model to output a probability if a number like 0.92 rather than directly outputting the word pass or fail? Because computers, let's say, talk in numbers. Okay, hold on. That was a guess. However, I had a question. How does the linear regression calculate? Like, how does it do the math to conclude if something is pass or fail? And that where do people often use it, and why do they use it? Okay, and then I'm just gonna go ahead and let's say send it. Not sure if that's what Claude is talking about. I see. Okay, let's pump the brakes and take these on one at a time. You just stack 3 different questions together, and mixing them up is exactly how 75% in land happens. Slow down first. Your guess. Computer talks in numbers. That's true, but it's not really why. It's not really why here. Every model outputs numbers, including linear regressions as price predictions. That's not what makes probability special for this case. Let's not move on from this until it actually clicks. So hold that thought. Second, it needs to correct something important because it classifies linear regression down, not decides pass or fail. Logistic regression does. Wait, we were talking about linear and logistic. Oh, never mind. This is more mathematical. Oh, I see. Wait. I think I understood where I got confused. What the hell? We were working with logistic regressions, and the topic before logistic regressions were linear regressions. I confused both of them to be the same because they sounded kind of the same, like logistic and linear. Okay, wait. I need to. They're 2 different categories. Oh, God. Okay, so second, I need to correct something important before it classifies or calcifies. Linear regression does not decide pass or fail. Logistic regression does. Okay, that makes so much sense right now. Linear regression applies the gradient, what was that gradient stuff I forgot? Gradient in intent? Something like that. Gradient intent, there we go. These are 2 separate tools for separate jobs. Linear regression predicts a number with no ceiling, price, temperature, age, what we did last hour. Logistic regression predicts a category, pass/fail, spam/not spam, what we're doing right now. They sound similar because of the names, but they're not the same. Math for the same job. Keep them in separate mental boxes, alright. Now the actual Y probability answer, mechanically, not geometry. Imagine the model just tried to output pass or fail directly as words with no probability step. Gradient descent. Okay, this was the word that I was looking for. The trial and error nudge, your guess based on error method. The trial and error nudge your guess based on error method from earlier needs a number it can nudge up or down a little bit to slowly reduce errors. You cannot nudge the word pass slightly closer to correct, but you can nudge 0.60 to 0.6. Oh, I see. Okay. 0.60 to 0.65 to 0.71. A probability gives gradient descent something smooth and adjustable to work with. The word only gets decided at the very last step after training is done. Quick check on that specific point. Does that make sense? Oh, why gradient descent needs a smooth adjustable number? Oh, I see. How both of them make sense now. They work together. Linear regression uses a trial and error and produces, let's say, numbers. Which number? Okay, numbers. And those numbers are sent to, let's say, those numbers are sent to the logistic regression where it checks if the number is close, is at least greater than 50% close to the actual answer. If it is, let's go with something like, if it is, it says pass. Else, it says fail. Okay, and then let's send it. Stop right there, that's a real misunderstanding forming. Oh wait, never mind. And I'd rather kill it now than let it classify or calcify. Good news, your instinct that trial and error produces an adjustable number is correct. Okay, so the linear regression part was correct. But the rest of the picture is tangled. Let's untangle it piece by piece. They do not work together in a pipeline. Logistic regression is not a second step that receives linear regressions as output. They're two separate independent models. You pick one or the other depending on what you're trying to predict. You never use both of them together on the same problem. Second correction, it's not about being 50% close to the actual answer. Nothing is compared to the actual answer. At prediction time, the actual answer is unknown. That's the whole point of predicting. The 50% is a threshold on the probability itself. If predicted probability is greater than 50% pass, if less than 50% fail. That's it. No comparison to a real answer happening there. Okay, wait. Okay, they're not working together in a pipeline. Second correction is not about being 50% close to the answer. Nothing is being compared. Oh, I see. The actual answer at prediction time, the actual answer is unknown. That's the whole point of predicting. The 50% is a threshold on the probability itself. If prediction probability is greater than 50%. Okay, I think I see. Let's rebuild this cleanly side by side. Linear regression versus logistic regression. Predicts a raw number, no limit. That's what linear regression does. Logistic regression predicts a category via probability. Linear regression examples could be house, which costs $310,000. An example of logistic regression could be pass/fail. Linear regression trained by gradient descent nudging m, which is the slope, and b, which is the y-intercept. Logistic regression is trained by gradient descent nudging m and b. Wait, is it just me, or are they like... They're sort of similar, not complete. Linear regressions is final output, the number itself straight up. Logistic regressions final output is probability, then threshold at 50% into a category. Both use gradient descent to train. That part of your instinct was right, both learn. MNAB. The difference is only what happens to the output at the very end. Linear regression hands you the raw number, as is logistic regression takes that raw number and squashes into a 0 to 1 probability first, then makes a yes or no call of that. Before we go further, say back to me in one words. What sentence are linear and logistic regressions used together, or are they two separate tools you pick between? They are two separate tools that we pick. There we go. However, I feel like I still do understand, but at the same time I do not. Okay, I would not be able to explain this to anyone. Oh, anymore. Guys, that's the difference with like touch typing. Sometimes your muscle memory takes over and you type, it's like auto typing. I type the word that I type the most, if that makes sense. Okay, good. That sentence is correct, and it's the important one, so lock that in. Now, let's name what's actually happening, because I understand, but I couldn't explain it. Isn't a math trace a specific normal stage? You have the pieces, probability, threshold, gradient descent, separate tools, but you haven't built the one clean through line that it connects them into a story you could tell start to finish. That's not a failure. That's exactly what happens the first time you meet a new concept before repetition sets in. Completely expected as a... Oh, wait, hold on. Hands off anything that is not distracting. Oh god, I'm late. Okay, so apparently I'm pretty sure I missed a bunch of conversations here, but Liang Yu says, Yang, thanks to you, we slipped past the auto puppets and TDs, tacit discards. We were blessed to make it with no losses.
As long as everyone is safe.
The hold is just ahead. Once we catch our breath, I'll have the guards clear passage and escort everyone inside. As for your case, the commander has been collecting intelligence by rafter kite. Once we reach him, we can decide our next steps together.
I kind of wasted like 20 seconds there, but that's fine.
Understood. And with any luck, Mengzhou may already have reinforcements on the way.
I hope that is the case.
Wait, are we gonna have to like fight a bunch of tacit discord armies? What's happening? Wait, what? Didn't she? We're being attacked. Wait, are we? Was she just seeing? Did she predict the...
avoided all of them.
She should have avoided all of them. What happened?
Fire the signal! Rally the hold support!
Oh wow, guys, I freaking jinxed her. We're gonna have to fight a whole freaking army of tacit discards.
They're too fast. There's no time. Battle lines! Cover the civilians! Buy them time to fall back!
That won't hold. We're outnumbered 3 to 1. The line will break.
Uh-oh.
Yang Yu, one of us has to stay behind to hold them off.
Let it be me.
Then let me stay.
Don't let me stay. I
Liang Yu,
want to.
You are a captain now. Don't lose sight of that.
Let me stay. I want to
I'll
do the
play
fighting.
decoy and draw them away. Trust me.
Let's go.
I've done this before.
Guys, I've been in a storyline for all my breaks. Let me do some action.
There are too many for one. If you ask me, we need 3. At least 3.
All right.
You! Watch Liang Yu. The hold is answering our signal.
My god, it trusts me. With a minute and 53 seconds.
Liang Yu, I'm not making it. Go.
What's happening?
Stay calm.
It's the...
Liang
It's
Yu.
the...
You
It's the
must
flat.
Stay calm. Make the right call.
I'm waiting for them to be done talking.
So everyone gets to.
She made a wrong call before. That's the reason her comrades died.
Yanlang, Mingyu, go to help Yang Yang. Everyone else fall back! Stay in formation, fall back as fast as you can!
Yes!
Oh wow, they're already here? Okay.
I need to lead these autopods another way.
Okay. At least I got some teammates.
Against the wind.
Against the
Speeding
wind.
up. Beware.
Hostile presence detected.
No one can hold that many alone. Don't let them surround you.
We wardens know these autopilots better than anyone. There's no way we let a Jinzhou Midnight Ranger bait them off by herself.
You. Thank you. Both of you.
Guys, guess what we're doing right now? It's basically button mashing the frick out of this.
Shape the shapeless.
Shape the shapeless. Alright, that's it. Hands off anything that is distracting. Back to work, back to work. There we go, back to work. Okay, I'm gonna get my timer here. That's it. Where was I again? Okay, good, that sentence is correct, and it's the important one, so lock that in. Let's name what's actually happening, because I understand I couldn't explain it. Okay, did I read this part? Nope, I did not. Okay, is in mastery, it's a specific normal stage. You have the pieces, probability, threshold, gradient descent, separate tools. Read that part. Let's build that throughout Thorline once slowly as a single story. No code, no jargon dropping, just the sequence. You want to predict, will the student pass or fail? You pick logistic regression because that answer is a category, not a number. The model starts with a random guess, M and B, just like before. For each student, it calculates a raw number using M multiplied by hours underscore studied plus B. Same formula shape as linear regression so far. Okay. That raw number gets squashed into a probability between 0 and 1. We haven't covered how that squashing works yet. That's the next real piece called sigmoid function. Don't worry about it yet. Gradient descent compares that probability to real known outcome in the training data. Did the student actually pass or fail? And nudges M and B to make future probabilities more accurate. Once trained for a new student with unknown outcome, plug in their house studied, get a probability. If greater than 50%, call it pass. If less than 50%, call it fail. Read that slowly in your own words. Just try the whole story back. To mean 2 to 3 sentences, start to finish. Don't worry about getting it clean. Okay. So apparently, we want to predict if a student passes or fails. Therefore, the machine or a machine generates a random number which later gets evaluated using a formula. Okay, m multiplied by, let's say, whoops, where's asterisk? M multiplied by hours underscore studied, STU, studied plus B. Okay, and then we use a sigmoid function, okay, which I don't really know what it's about, which I do not know about, and somehow the raw number, okay, and then the gradient descent compares the probability to the real known outcome in the training data, like student, and then using gradient descent we predict if the student passed or failed. Okay, that said, I believe that I may understand. Oh god, are you kidding me? I may understand this topic much better if we get some practice. Therefore, can we continue what we were working on and then get some hands-on practice question mark? There we go, and then I'm just gonna go ahead and let's say send it. That's actually a solid retelling. You got the sequence right, formula first, then squash into a probability. Every correct naming, even correctly name the piece you didn't know yet, sigmoid, instead of predicting you do. Then gradient descent trains it. Only one small correction, gradient descent isn't a step that happens after the sigmoid. A prediction time, it's how a model trained beforehand. Back when I was learning the right M and B in the same place, once training's done using the model is just steps 4 and 7, no gradient descent involved anymore. Small distinction, but a real one. Training happens once, predicting happens every time after. And I just realized something. I realized that was... Can someone check if I was streaming vertically as well? Because I forgot to close my vertical stream, even though I did not set one up. So I don't think that my stream was encoded twice, right? Once training's done, using the model is just steps 4 and 7. No gradient descent involved anymore. Small distinction, but a real one. Training happens once, predicting happens every after. Oh, I see. And yes, you're completely right that this needs hands-on practice to actually solidify. That's exactly the move. Let's do it. Quick note before we write code. Logistic regression in Scikit-Learn handles the sigmoid squashing internally. You don't write that math yourself. Same as .fit method hit gradient descent from your last time. Task, you write and run this one yourself. Small data set, hours studied versus pass 1, fail 0. Hours equals to 1, 2, 3, 4, 5, 6, 7, 8. Result equals to 0, 0, 0, 0, 1, 1, 1, 1. 0 is fail, 1 is pass. Here's the code's shape. Same pattern, linear regression, just a different class. From Scikit-Learn.linear_model, we import logistic regression as opposed to linear regression, where we create an hours as variable and we have 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, all the way up to 8 hours. For results, we have a list of 4 zeros and 4 ones. Then we create a models as variable that is equal to our logistic regressions as a function. And then on our models as variable, we call the .fit method. which requires hours, which I'm assuming is the slope, and result, which I'm assuming is the y-intercept. Prediction is going to be equal to model.predict a list of 4.5. Basically, everything is the same here. Literally everything is the same. Why do I have my notepad on? Oh, I'll just leave it on. I'm gonna grab Visual Studio. And then before I really work on this, I'm gonna drink some water because my god, I'm really dehydrated. Hold on, let me drink some water. That is the second time I've been hydrated in about almost 2 hours, shy under 2 hours. Yeah, I gotta be more hydrated, like what the hell? Okay, that's it, that's it. Let's go ahead and write the program here. So, first things first, I'm gonna go ahead and let's say add an import statement. Wait, actually, I'm gonna sort of change my Scikit-Learn to, let's say, linear. I don't know, linear underscore. Wait, you know what? Let's go with linear underscore regression first. Okay, and then I'm gonna create a new folder. This folder is gonna be called Scikit-Learn. Okay, and then linear regression goes under Scikit-Learn. I'm gonna close my Python file. Okay, and then this is linear regression. Now I'm gonna create another Python file called logistic. logistic underscore regression.py. There we go. Okay, and then in my logistic regression, I'm gonna go with, let's say, an import statement. So from sklearn, Learn, dot linear, linear, underscore model. I want to go ahead and let's say import logistic logistic regression. And then I'm gonna go ahead and create an hours as variable. Okay. What are the two things that we needed? I'm trying to do this with my mind besides the import here. So we needed hours and was it pass or fail? What was the second one? I forgot. The ones and zeros. Result. Okay. So hours, which is going to be our slope, is going to be equal to a list of 1, a list of 2, a list of 3, a list of oh my gosh, a list of 4, and then I'm gonna add a list of 5, and then I'm gonna be adding a list of 6, and then let's go with a list of 7, and then a list of 8. Okay, that's pretty much it. Now let's create our y-intercept, which is going to be our results. Okay, so there is a 50% chance. So a 50% chance could be that I failed. So I'm going to go with 0, 0, 0, 0, or 1, 1, 1, 1. I want to add some spaces because, you know, why not? There we go. Okay, and once we're done with this, I'm gonna go ahead and let's say create a models as variable that is going to be equal to my logistic regression. There we go. Okay, and then once I'm done with that, I'm going to go ahead and use the fit method on my model variable. The fit method is going to go ahead and perform a formula which requires two parameters, my slope, which is going to be my hours, and my y-intercept, which is going to be my results. I just like using the fancy words. Okay, so what it's basically going to do is the slope multiplied by, what was it? What was the formula? Hold on. Wait a minute. Wait, what was the formula again? I'm just gonna scroll a bit higher. There we go. 100 multiplied by square feet plus b. Slope multiplied by square feet plus b? What? Typo in import statement LOGESTIC. LOGESTIC. LOGIS. Oh. Hold up. Wait, I think I added a typo in my actual file name too in that case. I'm gonna rename this to be LOGISTIC logistic. Oh, LOGI. Wait, C, right? Okay, logistic. Okay. And then once I'm done with that, I'm gonna go ahead and train my model. So I'm gonna go with model dot. I'm gonna add a prediction for my model. This is the part that I kind of forgot how to do. Okay, so we're gonna create a prediction variable that is going to be equal to, let's say, my model.predict. Okay, which is gonna be equal to, let's say, a list of 4.5. Okay, and then we're gonna add our print statement. I'm gonna go ahead and let's say print an F string that says prediction. Good to have me here. Actually, yeah, I'd be struggling figuring out where I messed up. Then later I'd go and ask Claude where I messed up. Just a typo. I'd be like, what the hell? Okay, let's go with PREDICTION. Prediction is gonna go ahead and be my prediction variable. There we go. Okay, and I think prediction for 4.0 hours studied. Prediction for 4.5 hours studied. And then I'm gonna hit Control S to save the code. Let's go ahead and go with Control / to get my terminal here. First up, I'm gonna change my directory before I run my program. I'm gonna change my directory to Scikit-Learn. Because this is like my file name. Okay. Oh, wow. Scikit-Learn. Oh my gosh. Scikit-Learn. There we go. I'm just gonna copy this. And then I'm gonna get my terminal back up here, pasted. Once I'm in Scikit-Learn, I'm gonna go ahead and run my Python file. So I'm gonna go with something like py. And then a logistic, LOGISTIC, logistic underscore REGRESSION.py. Okay, and then I guess let's wait for it to run. Prediction for 4.5 hours studied is gonna be 0. I'm assuming 0 is false, right? Okay, 0 is fail. I'm gonna make sure to add that. 0 equals to fail. Okay, hold up. It's Python, right? So lowercase. It's not false, it's fail. Okay, 0 equals to fail. And let's go with something like 1 equals to pass. Control A, Control C, Control S. I'm gonna grab that. I'm gonna go ahead. Wait, actually, screw that. I'm gonna grab that. This is all Claude actually needs. And then say, I see. Hey, today is a day off though because there's a parents-teacher interview at my school. Oh, I see. That's it. How's school going, Formidable Thunder? Okay, good, real output. And notice you've moved your file into a new folder, Scikit-Learn too. That's fine. Just flagging it so we both know where things live. Just flagging it so we both know where things live going forward. Prediction 0 fail. Let's actually think about whether that's surprising or not because I see isn't quite reasoning through it yet. 4.5 hours sit exactly between 4 hours, which is a fail, and 5 hours, which is a pass. Dead center, so you might expect it to be a toss-up right on the 50% line, but it landed on fail, not some ambiguous result. Why? Here's the mechanical reason. The model doesn't know 4.5 is exactly in the middle. The way we do by eyeballing it, it found the M and B, the slope and intercept, that best fits all 8 points using gradient descent and not just the two closest to 4.5. The transcription point where probability crosses exactly 50% depends on the whole shape of the data, and it does not have to land precisely at 4.5 just because that's visually the midpoint of your two closest values. Let's actually see the number behind the label instead of just the final pass/fail. This is the equivalent of .predict versus .gof underscore .intercept underscore from before at this line. So we go with something like model.predict underscore prob. I'm assuming that's a probability. Pretty good, but I'm in a weird place. Huh. And I still go to high school, but do university there. I see that actually sounds kind of cool. Okay, so probability fail/pass, we go with probability. Predict underscore prob gives you the actual probability for both class before the 50% threshold gets applied. Before running prediction, given the final answer was failed, do you think the pass probability will be closer to 49, razor close call, or something much lower like 20-30? I think that it would be a close call like 49%. Okay, and then let me go with something like, I will run it to confirm. Let's go with something like, I'll run the program to confirm. Okay, and then I'm just gonna fix my typos. Hold on. Okay, I'm gonna go here with my output. Whoops. There we go. Okay, so I'm gonna go ahead and grab my Visual Studio here. And rather than having just the model.predict, I'm gonna go with model.predict underscore prob. And then this is just gonna be my prediction, okay? And then I'm gonna go with Control S to save the code, and let's run the program. Okay, this should give me my probability. Prediction for 4.5 hours studied is 0.500269. 0.499999731. Oh, it is really close. But it still failed. It didn't round up, so is rounding up not allowed? It is pretty close. However, is rounding not legal here, question mark? Nailed the prediction due on reasoning, not against. You said close to 49, and that's the real output, 49.999731. That's about as close as the prediction can get. Good instinct. Okay, good instinct there. Now your question. Is rounding not legal? I think you're asking why the model didn't just call this one close enough to round the pass. Let's be precise about what's actually happening, because this is an important rule, not a quirk. Look at two numbers, 0.500296 and 0.4999731. First number equals to probability of fail, class 0. Second number equals to probability of pass, class 1. They must always add up to exactly 1.0. That's not optional. Oh, I see. That's what makes them valid probabilities in the first place. There's a threshold rule. Okay, the threshold rule is strict, not a close enough judgment call. Whatever probability is, even half a hair lighter wins. 50 points, whatever that is a fail. Technically higher than 49.999731 is a... Wait, what? Whichever probability, even a hair higher wins. Fail is technically higher than pass. Oh, I see. Okay. By a razor thin margin, but higher. So the model, it fails. So the model calls it fail. There is no rounding step, no human style, and that's basically 50 by 50. I'll be generous. It's a hard, exact comparison every single time. This is actually a good real-world lesson. This data point sits almost exactly on the model's decision boundary. the point where this confidence flips from one class to other 4.5 hours for this model is nearly the precise line between probability fails and probability passes. One clarifying question so I know you've got the concept, not just the number. If you tested 4.51 instead of 4.5, do you think the prediction would likely flip to pass or stay fail? Okay, I believe that it would move on to be a pass. Because we were off by just a hair. However, I cannot reason through it without testing it out. Therefore, let me run it real quick. There we go, and then I'm just gonna go here real quick, and we're gonna go back to our Visual Studio Code. Studying at a polytechnic, which is a university that focuses on science and technology and generally provide the work digitally. I see. You can imagine it feels weird being one of the only 21-year-olds when most of the older students in the final year are 18 and 19. You know what? I think that's kind of relatable. What the hell? Okay, I'm gonna change this to 5.1, and then I'm gonna hit Control S to save the code, and then we're gonna copy that. Then let's paste it here. Okay, alright. And now, what in the genuine world is my second number? Okay, why is my second number what it is? Hold on. Alright, this second output is something that I never predicted. Why is the first number smaller than the second number? Okay, that's it. Hands off anything that is not distracting. Moving on back to Wuthering Waves, I just realized that I have an expedition motorbike. What the hell? When did I get this? Okay, I do remember I got this the other day, but still. Okay, this is our fourth session of our break, so it is going to be a 15 minutes long break. So you guys can walk, scroll, do literally anything if you guys are working with the whatchamacallit, with the Pomodoro as well. Yeah, I'm just gonna skim over this thing because I don't want to waste time here. Back to the Tacit Discord outrage. I so love offline games. You can always pause and come back to it. You cannot currently use this function. Alright. Wait, I gotta run. Hold off as long as you can. Oh, I said them to hold off as long as they can. Wait, there's more?
Let the winds roar.
Let the winds roar.
Hey. Hey. Ha. Persistence.
Wow, I can take on like 1,000 of them. Oh no! I left them for 1 second! I should have been. Wait, are they gonna die? Is he dead?
Mengyu! Damn you! Die!
He died. No, he's.
It's finally over.
Please don't die. Guys, why does it actually hit me in the heart?
I'm sorry. If I'd only gotten here a little sooner.
I literally left them for a second.
Now you sound just like little Yang Yu.
Are there any healers?
I'm alright. Just need to rest. Some rest and I'll be fine. A pity. That boy, Mingyu.
Okay, at least he's alive.
Quite a few girls had taken a shining to him.
Is he dead? Darn it. Rest in peace. The wind's coming back. I'm assuming she's gonna get a flashback again or a prediction of the future or something like that. All been silent. Okay, so explore ahead. Wait, what? Oops. Wait, I can use a motorbike! Oh, wait, never mind.
Sonaro. But how did I?
Naro.
Is it over? Xuanling, tell me. Yuan Fortress, did it stand? Please. I still had things I wanted to say.
Oh no, is he dead too? Oh, wow, he is. Why did he disappear though when he died? Wait, was that just her memory or... No, we did explore, didn't we? Investigate the battlefield. Injured Huangfang Warden.
Are you alright?
Are you alright?
I think. I can't feel my legs.
Uh-oh, is it a spine injury?
Where's everyone?
Did he brain damage as well?
Don't know. Not many left, I guess. We hold off the first wave for the next one.
Hey. Xuanling. Do you think we'll win this?
I think we will.
Either way, I'm afraid neither of us will live to find out.
Be optimistic, Gramps. Investigate the battlefield, okay. Wait, is he even Gramps? It said Warden, right? Oh, he's young.
Speeding up.
Don't worry, we'll all make it out.
Xuanling. Are those Xuanling birds? Thank heavens. You didn't all. Go. Go now. The village is all ready. Promise me. Go and see if there's still anyone. Take them away. Away from here.
Okay, investigate the battlefield. We're still investigating.
Speeding up.
Why? Why?
Why does it look like holograms? Like, what?
I don't want to die. I can't die.
My brothers and sisters, my parents, my wife and children, they're all waiting. Tacit discords! Tacit discords! Those cursed, wretched tacit discords! Killing you 100 times, no, 1,000 times, would never be enough!
Wow. We're still navigating the battlefield? Alright. Better drink some water.
First regiment is breached! Second regiment! Hold the line! Do not let the discords keep moving! Don't give them an opening! Damn it all! Where are our resonates? Are any of them still alive?
How many battles have been fought in this place?
Wait, did you see the bust of a person?
How many more are still to come?
Or like people or places? Can she see the...
They just keep flooding in.
She feels the burden of the people around her. Is that her special power? Oh wow, follow the sound of singing. I cannot run. They expect me to walk 22 meters. Okay, it's not as far. Fly on, Huangling. Fly with skies boundless, land wide. Oh no. New trophy unlocked. Alright. What was the trophy though? I couldn't see it. It went quick.
Don't cry. Don't cry. Let the Xuanling hear your song. Then they'll come. They'll come to take you home.
Wait, why is this Loki so sad? This entire game. I feel like freaking crying every time I play this stuff. And yet she let another life slip by her hands. The pain, the grief, the sorrowness. Fly on, falling, fly on, rivers. Okay, I don't want to get a copyright, so you guys can read the lyrics up there. I want to hear these songs so bad. What the hell? I'm just complying with YouTube's copyright things. I cannot have songs. You guys can read the song on top to the top left. Moonlight shines, the shadows stretched long. My voice travels far and wide, saying forget me not. Is this like a poem? When I hear this song so freaking bad. Now she's crying. This is so sad. Wait, what are these blue things beside her? The souls? Is she gathering the souls? Skies boundless, land wide. Bright moonlight. Cold night. My voice travels far and wide. My voice says, Father and Mother, worry me not. I'm gonna cry. What the hell's happening? It's all white and bright. Is that forward? Is that the creepy mask guy? No, it's the villagers.
Another wave of tacit discords will be here any moment. Good. Then we have arrived at the right time.
Now
Our
they're coming.
orders are to reinforce the western second front. Fellow artisans, ready the blade puppets.
Alright, I appreciate them coming, but couldn't they have come like a few minutes earlier?
George Atelier has poured years into this generation of blade puppets. There is no better test than real combat.
Wait, blade puppets.
Yuan Fortress was built by the Ministry of Development and George Atelier. It is the pinnacle of human intellect. Mindless tacit discords cannot be allowed to undo that. Yes, sir!
Interesting. Oh, he's ready in formation. Feels so bad for...
George and Atelier. Liang Yu mentioned them. A Mengzhou organization devoted to the mechanist arts.
Excuse me?
Please tell me there's not going to be another story. I got 13 seconds. I got 13 freaking seconds on the clock. Is it paused?
I'm back?
Oh god. Oh god, yes! Alright, time's up, time's up! Hands up anything that's not distracting. I'm so glad I'm not getting to miss a story. I'm not getting to miss a storyline. That was peak. That's it, hands up anything that's not distracting. Back to work, back to work. Okay, alright, the second output is something that I never predicted. Why is the first, why is the first number smaller than the second number? Wait, first, look closely at what actually happened before we chase the Y, because you might be reading this wrong. You predicted pass for 4.51. Look at the output. This is the 4.51's output. First number fail, 4.97. Second number pass, 50.30. Pass is now higher. Oh, so it's more like pass and fail. Fail and pass, I mean. Prediction flipped to pass exactly like you predicted, so this isn't something you never predicted. This is your prediction confirmed. You called it correctly. A tiny nudge from 4.5 to 5.1 crossed the decision boundary and flipped failed to pass. That's actually a real good result to see with your own eyes. It shows the boundary is razor real, not fuzzy. I think the confusion is just why is the first number smaller than before? Compare the two runs at 4.5 hours. Okay, so they're basically categories. This is a fail category and that is a pass category. Fail was slightly ahead. Now pass is slightly ahead. More hours studied, higher chance of passing. The pass probability goes up and the fail probability goes down by the same amount. They still sum up to 1.0. That's expected and correct. More study time. Should you increase your pass probability even by a tiny amount for a tiny increase? Wait, gut check. Does it make sense now? Okay. I see. Okay, I was confused about the numbers and why they were what they were. However, thinking of them as categories makes a lot more sense. There we go. Okay, think of them as categories makes a lot more sense, where the left hand is fail and the right hand is pass. Okay, so that makes so much more sense. I think I got it. Good, that reframing is the right one and it's yours, not one I handed you. Left equals to fails, right equals to pass, and they're just two probabilities that always sum up to one, fighting for which one edges out the other. That's the whole mechanism. No more mystery numbers. Now you've covered real ground this session: linear regressions, end-to-end, train, predict, verify, with code instead of manual math, and logistic regression: score idea, probability first, threshold second. Decision boundary is hard exact line, not a fuzzy zone. Plus you self-caught a math error and correctly predicted a boundary flip before testing it. That's a strong two-topic session given we're past the hour mark and stacked 2 new concepts. Okay, let's see. Keep going into new material or wrap here for today. Wait, hold on. How many topics are left under the category that we currently are on, and how many are there in total? There we go. Because I'm not merely exhausted. Good question to ask before deciding. Let's map it out clearly, I mean. Here's the roadmap straight from the roadmap doc you're currently in. Classic machine learning, Scikit-Learn, one of the 3 subsections under phase 2 status. Regression, linear regression, done today. Logistic regression, just covered. Okay, note, logistic regression is technically listed under classifications on the map, not regression, despite the same name. Just flagging that so the map stays accurate, okay? Classification, proper, decision tree, random forests, SMV not started, so that's what we're gonna start with next. Clustering k-means, DB scan, database scan not started, dimensionally reduction, PCA not started. After classic machine learning finishes, phase 2 still has 1 more full section left, model evaluation. Okay, I think we can keep going in that case. I think we can keep going in that case. However, every time we complete a category, for example, applied math, I need MD file, which I already got. The regression, right? Was our next topic regression? Okay, classic machine learning. Once we're done with classic machine learning. Okay, the classic machine learning, which is Scikit-Learn, when we are done with dimensionality reduction, I need a MD file. Okay, just saying. But we can continue. And guys, ignore my typo. I am almost reaching my limit, but then I think I can still go on because I have been working on these topics. I think that my interior mid-singular cortex did kind of expand, so I can take in more information these days as well. In, let's say, gaming terms, I'd say I kind of leveled up. Okay, got it. Locking that in. An empty summary file gets generated once the entire classic machine learning Scikit-Learn section wraps up regression, classification, clustering, and dimensionality. Reduction all done. Same pattern as the applied math one you already have noted. Not due yet. We still have classification, proper clustering, and PCA to go first. Let's keep pushing. Next up, classification for this time decision tree. Have you ever used decision trees before, even briefly in any concept? I have not. Yeah, I'm brand new to everything we're basically working on here. Okay, never touched it. Perfectly fine. A clean slate again. Good news on this one. Decision trees are actually the most intuitive algorithm we've hit yet, because you already use this exact logic every day without calling it machine learning. Real world example first, since that's what worked last time. Imagine you're deciding whether to go outside today. You don't run some complex formula in your head. You ask a series of simple yes/no questions one at a time. And I'm just gonna check my OBS real quick. Okay, first sec I thought I wasn't streaming. Wait a second, and my webcam as well. Why is it not more to the right? There we go, that's so much better. I feel like I'm not center aligned. Whoops. Hold up. Okay, there we go. That feels like I'm more center aligned now. Then I'm gonna go ahead and cover that up. Nope, I'm more left aligned now. Wait a minute. Let's go a bit back here. And then front. And then I'm gonna go with Alt. Okay, there. I think that's good, right? There we go. Okay, that is so much better. I feel like I'm center aligned finally. Okay, speaking of which, never touched it perfectly. Clean slate, did all that stuff. Good news on this one. Decision trees are actually the most intuitive algorithm we've hit yet, because you already use this exact logic every day without calling it machine learning. Real world example first, since that's what worked for you last time. Imagine you're deciding whether to go outside today. You don't run some complex formulas in your head. You ask a series of simple yes/no questions one at a time. Is it raining? If yes, stay inside. If no, keep going. Is it below freezing? If yes, stay inside. If no, keep going. Do I have to be anywhere? Do I have anywhere to be? If yes, go outside. If no, stay inside. That's it. That's a decision tree, a chain of simple yes/no or this or that questions where each answer branches you towards the next question until you land on a final answer. A decision tree model does the exact same thing, but it learns which question to ask and in what order from your training data. Instead of you hard coding them yourself. Quick check before we go further using the go outside example above. What do you think happens if you answer yes? It's raining. Do you keep answering more questions, or does that decision stop right there? I mean, the decision would stop right there. Unless I want to be, let's say I want to be at a convenience store or anywhere that I could be using a vehicle or an umbrella. Okay, and then I'm just gonna fix my typos real quick. Hold on. Vehicle, convenience store. Okay, and then I'm gonna go ahead and let's say send it. Good instinct, and you're actually reasoning about it realistically, but let's separate two different things you just blended together. How the tree I drew works versus where the tree itself is a good/complete tree. Based on the specific tree I wrote out, is it raining? Yes, stay inside. With no further branches added after that, yes, it stops right there. That's exactly right, and that's the core mechanic. Once a yes slash no question gives a decisive enough answer, the tree stops branching and gives a final answer. No more question gets asked after that. Your point about umbrellas and cars is a really good one, though. It's correctly noticing that my example tree was oversimplified and does not capture every real nuance. That's true. A real decision tree could have more branches. Is it raining? Yes. Do I have an umbrella? Yes. Go outside anyway. More branches equals to more nuance captured. That's a valid critique of my example, not a wrong answer to the actual question. But here's the key distinction to lock in. That critique is about tree design, not about the core mechanic. The mechanic itself asks a question. Branch based on the answer, keep going until you hit a final decision. Stay exactly the same no matter how many branches you add. So cleanly, for the specific simple tree I gave you, does it stop at yes is raining or continue? Just the mechanic, not redesigning my example. It does not continue. Asking questions. Instead, it stops. Okay, and then I'm just gonna go ahead and send it. Okay, correct for that specific tree. Once raining equals to yes hits, it's a leaf, a final answer, no more branching. That's the mechanic locked in. Now let's name the actual pieces. Since you'll see these terms everywhere once we hit code. Root node. The very first question, is it raining? Branch, each possible answer, path, yes or no. Internal node, any further question down a branch, is it below freezing? Leaf node, the final answer where branching stops, stay inside, go outside. Here's the part that connects this back to everything you already know. How does the tree learn which question to ask first and in what order? That's not random and it's not hard-coded by a human either. It's learned from training data, same as slope and y-intercept were learned by gradient descent and regression. The mechanism is different though. Trees don't use gradient descent, they use something called information gain, built on a concept called entropy. Never heard of that word. What's it mean? Basically how mixed up slash uncertain a group is. Okay, let me drink some water real quick. Dehydrated as frick. Okay, basically, okay, yada yada. The tree tries every possible question on the data and picks whichever question does the best job of splitting your data into cleaner, more separated groups. That's genuinely as deep as we need to go conceptually for exposure level right now. Full entropy math is a rabbit hole we don't need yet. The plain English version, the tree picks whichever question splits your data most cleanly into yes people and no people first. Quick check on that idea before code. If you had data on 20 students, hours studied plus pass slash fail, and hours studied was greater than 5. Perfectly separated all passers from all failures with 0 mixing versus a favorite color, which split term randomly with no pattern. Which question do you think the tree would answer? Okay, let me say something like, before I answer that, can I get a different real world example question mark? Because I did not understand. I will continue the rest next stream with the same exact topic. However, I am trying to absorb as much as I can today, so I can, or let's say something like, so my brain can soak it up by tomorrow. Process it by tomorrow. Okay, and then I'm gonna go ahead and send it. Okay, good call. Recognizing I want a different angle before I answer instead of forcing a guess is exactly the right move, and stopping the topic here while wrapping the session separately is a smart way to let it sit overnight. Real world example, no student, no data, just people. Imagine you're sorting a huge pile of laundry into 2 baskets. Wash on hot and wash on cold. You could sort by asking different questions. Is it a color or is it white? This splits things pretty cleanly. Whites go hot, colors go cold. Clean split, barely any mixing. Does it have a pocket? This splits things almost randomly. Pocketed and non-pocketed items land in both hot and cold piles equally. Total mess, no real pattern. If you had to pick one single question to sort the whole pile with the fewest mistakes, you'd obviously pick, is it a cold or white? Or, wait, if you had one single question to sort the whole pile with the fewest mistakes, you'd obviously pick, is it a cold white? Is it a cold or white? Not, does it have pockets? Okay, that makes sense. Because that question actually separates the piles cleanly. White pockets question tells you basically nothing useful. That's exactly what a decision tree does when picking its first question. The root node, out of every possible question it could ask about your data, it picks whichever one splits your groups the cleanest, the color versus white questions, not the pocket question. Okay, sit with that one. No need to answer right now since you're closing the topic here, okay? Wait, before I really go, I wanna just go ahead and fact check something, because I think that's pretty much it. And well, I still do have, let's say, about 5-ish minutes. I could most likely ask Claude for... Should I ask Claude for MD file? Hold on. Let me go to my Visual Studio real quick. Okay, I would not really need a markdown file because I do have it here. Although I could actually work on uploading my stuff to GitHub. 365 days roadmap. Okay. Data pipelines. Was it this? Nope. Was it this? This? Okay, let me say, can you help me upload? Actually, let's go to a brand new file. That's gonna be so much better. There we go. Okay, let's say something like, can you help me upload something to my GitHub? There we go. Okay, I'm gonna send a quick little picture of what I wanna. I'm gonna go here and then I'm gonna say my phase 1. So from here. Okay, I'm gonna paste it and say, from here, I only want my phase 1 on GitHub. However, I still do have a few of those files already uploaded to GitHub. So is there a way to override those files and have one of each file on GitHub question mark? There we go, and then let's just go with something like send it. Okay, and while I'm at that, I'm gonna go ahead and let's say open my GitHub. You know what? Let me do it with you guys. You guys can get access to GitHub by typing exclamation GitHub on chat. Okay, that's gonna pop a link up. Shameless plug while getting my job done, because many of you guys do still ask me for the markdown file, so I still need to whatchamacallit, find a way to give it to you guys. Wait. What's wrong with the GitHub command? Is Nightbot not on yet or something? Interesting. Okay, I guess I'm just gonna go ahead manually. There we go. Okay, so in GitHub, I have already a few things in my AI Engineering's folder. I can help with this. Good. This one is set up. That confirms it. The sandbox has no access to your actual machine or GitHub repository, yada yada. What's currently in the GitHub repository right now makes up phase 1. I'm gonna go here. Let's just take a quick little picture. Only things that's in my GitHub right now. There we go. Let's say something like, these are the things in my GitHub right now. Only content from phase 1. However, I just recently created the phase folders, and then let's go ahead and send it. And why does the GitHub this thing not work? Did I spell it wrong? Exclamation Discord. Unable to connect to the chat. What's up with the chat? Why is it unable to connect? Okay. Alright, interesting. Let me try to refresh. Wait, can you guys? Oh, okay, it did work. For some reason, I couldn't. For some reason, I couldn't see it. I'm just gonna delete my Discord now. There we go. Okay, for some reason, I was the only one that couldn't see that stuff, but it's fine. Oh, I couldn't even see the new chats. Yo, hi doing, Sudeep. I appreciate you joining the stream. Edges out sounds a bit kind of sus, Kappa. That actually does. Okay, that's it. No wonder. I was like, I couldn't see the chats. I probably disconnected off the chats. Okay, got it. That's actually the simplest version of this problem. Since you just created the phase folders, your local structure now probably looks something like this. Python files, phase 1, yada yada. Nope. It's the complete opposite. I'm gonna have my phase 1 on. Okay. And I think that's time. Hands off anything that is not distracting. This is the way my folder goes. There we go. Hands off anything else not distracting. Back to Wuthering Waves. I'm gonna get this here.
Xuanfang is not exactly peaceful these days, young lady. This ground is dangerous. It would be wiser not to linger here.
Sir, that advice applies just as well to yourself. Wouldn't you agree?
A sword.
Oh, my apologies. I misjudged you. You carry a military blade, so you are a soldier, I take it. It's only that your face is new, and you do not dress like one of the wardens.
I'm with the Jinzhou Midnight Rangers. Why I've come to Xuanfang? It's a long story. Not for this place. Since you've questioned me, perhaps you can offer your own name and identity in return. As you said, this place is not exactly peaceful. A civilian wandering alone through these mountains is unusual, to say the least.
Of course. My name is Muyu. I am an artisan under the Xuanfang Ministry of Development. If you do not trust me, I have my badge with me. Yesterday, on orders from the Ministry of War, I went to a nearby censure court for routine maintenance. But before I even made it inside, I watched the auto puppets go rogue. They attacked the wardens escorting me.
What's wrong with his eyes?
I was fortunate. I lived, but I had to retreat deep into the cliffs. Only once I was certain the auto puppets had moved on did I dare come back out.
Alright, something seems wrong. Do not trust him. I do not trust him.
Then I found you here, looking rather shaken. Judging by the area around us, you must have endured quite a battle. Did you fight all these auto puppets yourself? Remarkable.
There's something about this man.
I know, the eyes are throwing me off.
Since you're a Ministry of Development artisan, let me escort you back to the hold.
This is no time to return to the hold. I must get to the Western Fang Peaks now. I must not dally.
The Western Fang Peaks. Why? What's there?
The Western Fang Peaks houses the Skyworks, Xuanfang's largest auto puppet production plant and tacit discord disposal facility. If that place falls, rogue auto puppets and tacit discords will spill into every corner of Xuanfang. The consequences are unthinkable. In truth, when I reviewed the patrol routes of the auto puppets days ago, I noticed a few had deviated from their assigned paths. Auto puppets are self-operating machines. At first, I assumed a few units had suffered minor faults in their circuits after fighting tacit discords. But now it seems the rebellion may have started from there.
I was like, is it just me or does it feel like it's gonna self-destruct?
And the point where all those rogue units' paths converged was the Skyworks.
So you suspect the answer to why the auto puppets went rogue might be there.
Precisely.
Oh my! Did I just jinx? Did I just say what he was gonna say? Did you guys hear me? Was I audible there when I said precisely too? Guys, I guess I'm in the story.
We still don't know why the auto puppets malfunctioned. If, as you say, auto puppets and tacit discords have gathered at the Skyworks, then how do you stay safe if you go there alone?
The Xuanfang artisans spent generations crossing mountains and valleys. That is how the hold was built. I have inherited a measure of that nerve. Besides, Xuanfang is now on a knife's edge. Everyone thinking only of their own survival is hardly a wise strategy. But still, young lady from the Midnight Rangers, your skills are extraordinary. Were you to come with me, perhaps my safety would be much less of a concern.
The disappearances in Jinzhou also began around that same time. I can't ignore this lead.
Alright, that's it. Time's up. For the time being, I will be canceling my timer here because I am pretty much done with today's, the Power Hour session or my programming in general. I will be uploading all the content to GitHub just after I'm done with the story part here because I don't want to leave the story uncompleted or I'll have to start from scratch tomorrow.
And whether he's telling the truth or not, I can't just leave this man on his own. All right, I'll go with you.
This is something what I call
Then let's
overtime.
not waste another second.
If a robotic bird, can she like communicate with these birds or something? Okay, am I done with the story? Because I don't want to like overtime a whole lot.
But the ruins
New
of Yuan
trophy.
Fortress lie between the eastern and western Fang peaks.
Archers.
How do you plan to get there?
That is no problem. We artisans know every mechanical structure in the land of Xuanfang, and that includes Yuan Fortress. There's an old passage through the ruins that connects to the Western Fang Peaks. Rarely used now, but I know of it.
Okay, so it says follow Miu towards the Western Fang Peaks. Damn, I love the humming. Okay, never mind, humming's gone. Do I follow him? Because I'm scared if I don't follow, I'm gonna lose my progress. Wait, he's not going anywhere, right? He's just standing there. I think that should be pretty much it. Okay, it is pretty much it. Alright. I guess I'm gonna move on to my OBS in that case, and then let's go to my main camera. There we go. And am I not centered? I think I am sort of centered. Alrighty guys, so basically that was pretty much it for the stream. If you guys did enjoy the stream, don't forget to smash the like button, subscribe with notifications turned on, and if you guys do enjoy my content / videos, make sure to share it and whatchamacallit, share them in general because like keeps my algorithm sharing, makes you smile, and subscribe link at your top. That said, I will try to multi-stream. Like one of you guys did say this, one of you guys did ask me this stream if I am also going to stream on Twitch. For the time being, I do not because streaming simultaneously across different platforms does decrease my video quality across all the live streams. However, if I do use restream.io and stream using that on, let's say, Twitch and YouTube at the same time, I'm pretty sure it wouldn't really compromise my stream quality, so I will be trying that stuff. That said, if you guys do want to follow me in any of my socials, you guys can get access to all my socials through the link in the description, through my bio, or by typing exclamation at the name of the social on chat. If the social does exist, a link is going to pop up within 3 to 4 seconds. If the social does not exist, a link will not pop up. That said, I did create 2 brand new channels, one called Viv Arcade and the other called Viv Works Out. Viv Arcade is specifically meant for my gaming content and Viv Works Out is specifically meant for my workout content. Therefore, if you guys are interested in either one of those genres or categories and that you guys want to follow me there, you guys can get access to both those channels through my homepage. If you guys scroll all the way down, you guys will be seeing a featured section, a featured channels category where I will be having both those channels featured. And also, if you guys do want to follow me in my AI engineering for 365 days series and that you guys want access to the roadmap that I am currently using for this series, you guys can get access to that roadmap through my Discord server. If you guys either go to the Coding Helps chat, Python chat, or the general chat, mention my name there at VivUniverse, asking me for my roadmap. I will be personally DMing it to you guys. And you guys can get access to my Discord server, again, through the link in the description, through my bio, or by typing exclamation Discord on chat. That said, I will be uploading, let's say, my phase 1 on GitHub today if I had the time. And I'll catch you guys next live stream or video. Peace. Okay, I guess let's end the stream.